Okay, welcome to this continued series on radicals, a very big topic as we said, but I wanted to show you lots of examples so you can see various things that can happen. We're in the midst of solving some various problems right now. We're simplifying using the concept of a conjugate, right? So pause the video, try this one. Okay, if you did this correctly, what you would have done is taken the conjugate of the denominator, which in this case includes 2 square roots. All right, so let's do this. On the top, we have 4 times the square root of 5 minus 4 times the square root of 7. And on the bottom, we have square root of 5 times square root of 5, which is 5. And then we have square root of 5 times negative square root of 7, so that's negative square root of 5 times square root of 7. And then we have positive square root of 5 times square root of 7. And then we have positive times a negative, which is negative, square root of 7 times the square root of 7, which is a 7. So I have 4 square root of 5 minus 4 square root of 7 over, these cancel, and I have 5 minus 7. So that's 4 square root of 5 minus 4 square root of 7. Actually, I'm going to factor that 4 back out. Let's say that that's 4 times the square root of 5 minus the square root of 7 over negative 2. And the reason I want to do that is so that I can factor the top into 2 times 2 times square root of 5 minus square root of 7. And the bottom I'm going to factor into 2 times negative 1, so that the 2 divided by 2 gets to go away. And I'm left with negative 2 times the square root of 5 minus the square root of 7. So I might have the answer written this way, or maybe it would multiply out, and I would have negative 2 square root of 5 positive 2 square root of 7, right? Those are both correct forms for the answer. Okay, so you still use the conjugate even if you have 2 square roots. Okay, so last topic, multiplying, dividing, adding, subtracting radicals. Okay, so first of all, multiplying radicals. Multiplying radicals is very straightforward. Since there's no pluses or minuses here, you just multiply everything that's outside of the radical together to combine it into a single value, and everything that's under any radical can be multiplied and put back together into a single radical, and you can continue simplifying. So let's say I had this. I had 3 square root of 7 times 4 square root of 7. Well, the 3 times the 4 is a 12, and the square root of 7 times the square root of 7 is a 7, right? Because square root of 7 squared, the square root and the square cancel. So you'd have 12 times 7. What is 12 times 7? 12 times 7, 2 times 7 is 14. 7, 8. So it looks like we have 84. This simplifies to the number 84. That doesn't always happen though. This one over here, we have 5 times 6 is 30. Then we have square root of 2 times square root of 6 is the same as square root of 12. But I might be able to simplify that further. That's the square root of 4 times the square root of 3, which is 30 times 2 times the square root of 3. And then that's 60 times the square root of 3. So 60 times square root of 3 would be the simplest form for that. Okay? Okay, so for multiplying radicals, we just multiply everything outside the square root together, multiply everything inside the square root together, and attempt to simplify. Adding and subtracting, a little bit more problematic. Similar to variables, you can really only combine terms that have add and subtract them if they are like terms. Same as with variables, right? If you had something like 3x plus 4y minus 8x, you would combine the x terms and you would get negative 5x's, right? Same thing here. If I have 3 times the square root of 2 plus 4 times the square root of 3 minus 8 times the square root of 2, well, these radicals represent numbers, right? Square root of 2 is 1.414. Square root of 3 is 1.732, right? I don't want to be adding a 3 square root of 2 to a 4 square root of 3 because it's different quantities that are adding, right? But what I could do is say, if you have 3 square root of 2 plus 4 square root of 3 minus 8 square root of 2, I can combine the ones that are alike, right? Both of them that have the square root of 2 in, I have 3 times this number, square root of 2, minus 8 times that number, so I have a total of negative 5 times that square root of 2, and then I have 4 times the square root of 3 number, right? So if I'm going to leave it in square root form and not go to decimals, then I only want to combine like terms. Only if they have the same square root or cube root or whatever can I combine, okay? So try this one on your own, pause it, see what you get. Okay, so this one, all of the square roots are square root of 5, so I can combine completely. I have 6 minus 2, which is 4, plus 8 more is a total of 12 square roots of 5. So in this case, they do all combine. What about here? Well, it seems like I can't combine, and I can't combine yet. Square root of 45 and square root of 20 are different. But it might be that I can simplify and then combine. Would you agree that the square root of 45 is the square root of 9 times the square root of 45, and the square root of 20 is the square root of 4 times the square root of 5? That makes this 2 times 3 times square root of 5, square root of 5 here, not square root of 45. There we go. Yeah, 9 times 5 is 45, and 4 times 5 is 20, so I can split each of those square roots. And then I have 4 times 2 times square root of 5. So really, when I simplify, I have 6 square root of 5 plus 8 square root of 5. So at first I couldn't combine. But if I can simplify each radical individually and end up with like terms, then you can combine and get that this is 14 square roots of 5. All right, let's continue here. Can I combine here? No, but if I simplify each one, I'll be able to do some combining. So pause it, give this a try. All right, the square root of 27 simplifies into square root of 9 times 3, which is 3 square roots of 3. The 48 simplifies to 16 times 3, which is 4 square roots of 3. And the 12 simplifies into square root of 4 times square root of 3, which is 2 square roots of 3. Wow, they're all identical. So I've got 3 plus 4 is 7, plus 2 more is 9 square roots of 3 here. All right. Try it again. Okay, in this case, I've got square roots. How about 25 times 3? Which makes this 7 times 5 times square root of 3. So I've got 35 times the square root of 3. And for the 18, let's see, how about 9 times 2? So that's a 3 square root of 2. Let me bring that down here, 3 square root of 2. And then for the 300, that's a 100 times a 3, which is, let's see, that's going to be 10 times the square root of 3. Okay, when I'm done, I have a couple of terms I can combine, but I can't combine that with the square root of 2. So I have 35 minus 10, which is 25 square roots of 3, plus 3 square roots of 2. So I can do that much combining. But I couldn't combine it all until I simplified. Okay, so that wraps up this very long sequence of videos here. Thank you for listening to all of them. I know it's a laborious process, but radicals do have a lot of properties, and there are many, many different situations which can arise when simplifying. We probably haven't touched on every single one of them, even in these videos. But becoming proficient at working with radicals just requires practice. So if you keep practicing and questioning if you're having trouble getting the right answer, you'll be a pro before you know it. Just keep at it and keep checking the videos. Try the practice. Remember, the practice sheets have solutions so you can see what you're doing wrong if you're not getting the right answers. And you can always come in for help if you're on campus at Desert Vista, and come to the math office, and any of the math teachers can work with you on these ideas. Okay, thank you for your patience.